I'm Herschel George, and I'm one of the watershed specialists with the Kansas Center for Agricultural Resources and the Environment. One of our main priorities is water quality associated with livestock. Today we're visiting about watering systems in the wintertime. The main objective of our water systems is to make sure that all the animals get the water they need every day, even in the wintertime. It can be a bit challenging. I get to thinking about the equipment we have today, the alternatives we have today, compared to those that our grandfathers might have had in the earlier times. So what did the old timers do in order to water livestock in the wintertime? Initially, the flowing streams were the only source of water for their horses and livestock. I'm sure as soon as possible, these homesteaders would dig a well and pray for water. Well water allowed the producers alternatives to watering directly from the stream. After World War II, bulldozers became of greater availability and were used to make some of the earliest ponds. These ponds were not designed to be large. They were just a collection of a pool in a small intermittent stream. An axe would be used in the wintertime to break a hole in the side of these ponds in order for the livestock to have access. And yes, it did happen that some livestock would gather on the pond following a snow, and producers would lose 2 head, 5 head, 20 head. Part of the problem was these producers were encouraging the cattle to gather there at their chopping hole at the pond's edge. Chopping a hole for livestock to drink along a pond's edge is not a very desirable way to start your winter's day. Now that looks palatable, but some producers still do it. This gentleman is making a large hole for easier access, I'm sure. It takes a bit more time. He is even removing the chopped ice. But what is this? Or this? But I guess this is where we've been chopping the ice and training them to come. But when a light snow happens and covers the ground and the ice, it seems the cattle get a little curious, and then this happens. When cattle fall through the ice, it is normally not 1 or 2, but a number. We need to look at options to effectively get cattle away from the ponds during the winter. Ideally, livestock water pipelines are installed into a dam as they are being constructed, or they can be added after construction. A line through a dam allows the producer to utilize gravity flow to serve automatic waterers that are below the pond dam. We will discuss other options for watering livestock other than direct from the pond surface. From a water quality standpoint, watering livestock from the surface is a problem. We will discuss earth-sheltered concrete tanks. I sometimes call these behind the pond style tanks. We'll discuss some spring developments, also some tank heaters that can work in open top stock tanks, and some of the insulated and super insulated waterers that are out there now. We often don't consider it, but the source of the water makes a big difference in how easy it is to maintain our stock tanks in the wintertime. There can be as much as 15 degrees or more difference in the temperatures just based on where the water comes from. A well would have the warmest water in the winter because that water is insulated deep in the soil. Springs also are insulated well, but they come to the surface and they may be a little cooler. Rural water systems or pipeline systems are next because they may sit there at the frost line, 36 inches in the ground or so, for a long time, and so that temperature gets lowered down. But ponds are cold. In the wintertime, ponds are the coldest to start with, and then when we start trying to keep them ice-free, it becomes greater problems. Let's just think about this for a second. Consider you're using pond water at 40 degrees, which is only 8 degrees above freezing, compared to well water at 55 degrees, which is 23 degrees above freezing. That's almost a 3 times difference. Therefore, if you were using water from the water source to maintain the temperature in your tank, it would take 2 to 3 times as much water from a pond as it would from a well. These earth-sheltered or behind-the-pond style tanks are sturdy, reliable, and due to the warmth of the earth around the tank, can maintain ice-free water at lower temperatures than exposed tanks. These tanks do an excellent job of providing ice-free water in the wintertime. Maybe the limitation to these tanks is actually in the summertime because of the smaller drinking space they have. The hump of soil over the tank behind the baffle is what provides the insulation and makes this style of tank so successful in the wintertime. There are many types of these tanks. They all have similar float valves, they all have similar overflow pipes, and winter flow lines. The winter flow lines are opened for the wintertime to release water from the source that helps heat the water in the tank, as well as create some action in the drinking area. That helps to reduce the freezing in that spot. The excess water goes into the drain pipe, which is piped a distance away from the tank and exits out there so it does not create a mess right there in the front of the tank. The overflow pipe is located in the corner of the drinking area. When the main valve in the tank says it's full and stops filling, the winter flow valve continues to flow that 1/8 of an inch hole and will release water into the tank, keeping warm water coming in and helping provide winter protection. This is what the copper line looks like in another one of these types of tanks. This is a clip that I took on a 6° Fahrenheit morning. You actually can see the copper line in the bottom if you look closely. I truly think that these are an excellent choice of waters if your objective is to have totally ice-free winter water. They are easy to maintain, easy to work on. Here's another view of these concrete tanks. The mound of soil behind the tank helps keep this tank ice-free in the winter. When I was growing up, I remember hearing discussions about springs. What a great deal. But in our area, these springs were simply wet weather springs that kept the hillside wet. Just enough flow that in the wintertime a cow might come trampling through and drink from cow tracks. I think these wet weather springs are now incorporated into the drainage area of many of our stock tanks. When we discover a good spring, we recommend that it be protected from the livestock damage and the trampling. A spring development project is shown here in the drawing. I would like my coworker, Dr. Will Boyer, to discuss spring tanks with you, and then I will come back and show this drawing again.
We're here at a spring development site because it provides such a good example of a good winter watering source for several different factors. One, it requires no external source of energy. Gravity is what provides the water from a wet area up the hill here, down the hill into a spring collection box that separates the sediment out, and then the water flows in a pipe on down into the tank. A vertical pipe comes up, water comes flowing out of that, and then it's a full flow system, we call it. All the water that is coming into the tank is moving all through the system and coming right on out. And then the discharge water discharges out on a rock ledge over there next to the edge of the trees. So that's a full flow system dependent upon gravity. One of the other great things about a spring development is the warmth of the water. You only get that kind of water warmth in a water source besides a spring would be in a well. So that's another example of a good warm water source.
So how is that you develop a spring? Primarily, we will use some obstruction below the spring or wall to cause the water to pool above that wall. As the water passes down the pipeline, it will get to the livestock water area, and we use a T at that point to bring the water up to the livestock water tank. The other leg of the T extends some distance downstream so that we can put a shutoff. The purpose of this is so that as sediment accumulates in our pipe, we can open that shutoff valve and allow the spring water to flush down through there, cleaning out sediment that is in the line, and we're ready to continue. It is common to see open-top stock tanks used for livestock. They can be made of a number of different products: steel, polyethylene. There are even fiberglass. But these tanks are difficult to winterize and need to be chopped or something done to keep access to these tanks every day. There are a number of things that we can do to stock tanks to help keep them from freezing. One is to add warm water from a spring or a well or a pipeline or even a pond. Another is to place a heater in these. If you're near electrical power, you can use an electric heater or a propane heated unit. Adding insulation is always an alternative. One of the easiest, of course, is burying a portion of the tank so that it is under the soil and let Mother Nature help us keep it from freezing. Another is placing them out of the wind. My goodness, the wind chill is actually what causes the extreme cold on many of these tanks. One other thing that you can do is to try to cause movement or surface action, and that will help reduce the stratification in that tank and hopefully keep the tank from freezing. These tanks that do not have any automatic level controls need to be manually filled, but that can be to the advantage of the producer, because adding that water, that warm water, to these tanks can help thaw the ice accumulation that is there. The producer needs to learn how to manage how often they need to fill the tank so that the livestock have adequate water at all times, and yet they have enough volume when they refill to melt any accumulated ice in the tank. But many times it still requires the producer to take axe in hand so that the livestock can drink from this tank. Tanks with automatic level controls must have some method to keep the float open and in order to keep the automatic level to work. The most common method of keeping the water from freezing is using a tank heater and placing it under the float. There are basically two types of tank heaters: electric tank heaters and propane tank heaters. When AC power is available close to a tank, an electric tank heater can be used. The heating elements are thermostatically controlled. Some of them are submerged, as in this case, rest on the bottom, while others are floating units. Propane tank heaters can be used when you're away from AC power. They're often used with solar pumping systems. In this way, the producer can allow the automatic float controls to operate all through the winter, keeping it thawed out. In this case, the producer has a 100-gallon propane tank sitting just behind the tank. Other producers will use propane tanks similar to those that you use on your barbecue grill. More recently, we see the use of open-topped tire tanks. For wintertime, we like to use these smaller 4-foot diameter tanks so that we get more refills per day. Even a small group of 30 head drinking 10 gallons per day would result in 2 or more exchanges of water in this tank. Frequent refills brings in more warm water into this tank, reducing the amount of ice in the tank. The black sidewalls that absorb sunshine and solar heat helps reduce the amount of ice also. When utilizing gravity flow from a good pond, we can build in some winter flow into the system. When we are setting up these tanks, we add a P stream of continuous flowing water from the pond to create some surface movement and to continue bringing in that warm water into the tank. The excess water is drained from the tank through an overflow pipe that you see back underneath the edge of the tire. It is secured there to prevent the livestock from knocking it out of place. These tanks perform well with minimum effort. When we have a good pond, we feel we can waste some water to help maintain the water temperature. These ponds need to have at least 6 foot of head so that we can have adequate pressure to cause the movement we would like to have. This tank is about ideal for the weather. Note the drain line is about 1 cleat to the right of the P stream. These larger tanks are difficult to maintain in the wintertime. I have recommended that producers that want or need to use these larger 13-foot diameter tanks to consider installing a smaller tank nearby. These smaller tanks are easier to winterize. During cold weather, livestock water demands are reduced enough that these 4-foot and 6-foot tanks are adequate. And we simply allow the large tank to freeze during extended cold periods. Automatic waters, such as these by Bowman and Johnson, have open tops. They have their controls underneath the shields on the end. They're often installed on pressurized systems. When producers are buying these, they can purchase them with heating elements already installed. Here is an example of a special valve that is designed to release water. As the water gets colder, it will release some of this warmer water into the tank. There are a number of these. This is an ice sweeper. There are Walters valves, ice bowls, but they all operate by releasing additional water into the tank as the tank gets colder and colder. These devices are all thermostatically controlled and designed to release more and more water as the temperature drops. The objective of these is to keep the float valve from freezing up. The condition of your water has a great deal to do with the life of these valves. In my experience, these devices have much too short a lifespan compared to the life of the tanks. I think it's common that the water pool where the livestock would drink will develop some ice on the surface overnight. That will depend upon what the temperature is, what the wind chill is, as well as the number of livestock drinking from the tank. It also depends on how much water we release from our winter flow lines. Our objective is to have the valve that is underneath that shield on the end to not freeze and not have the float stick to the sidewall. We had struggled to find a valve that would allow us a fine enough adjustment at the low end of those flow rates. I'll show you what our solution was for these automatic waterers. These waterers come with a nice access door to get to the controls. Inside you will find the plastic valve body, the float arm, and the bullseye nozzle that we have chosen to use. The bullseye nozzle is actually a hose-end nozzle, like you would use on your garden hose. I adapted this from Brown weight valves. You can see the fine stream that it can create with the nozzle. This setup allows us to finely control how much water that we wish to release. I'll show you how the valve is adjusted. So I'm going to try to show you what I do to winterproof mine. This is a bullseye nozzle right here. And it is set so that I can turn this and it'll open the valve. I hope you can see that. See that little bitty skinny blow?
That's just about what I want. That's all I leak. And I let that run, and it will prevent my tank valve from freezing.
This is how the tank often looks when we check it in the morning. The opening in the upper left-hand corner of the tank is not frozen. In fact, it's not uncommon for the cattle to enlarge this opening and be drinking from the tank before we arrive. Here is another tank early in the morning. Note that there is at least a square foot of open water. There are a group of tanks I consider super insulated tanks. Most of these tanks have thick insulated surfaces, maybe 4 inches in thick, and often utilize earth tube type heating to help prevent the tank from freezing. This is a Cobat waterer. It is a super insulated tank that I talk about. This one has an open top. It's composed of a tube about 4 foot long vertically with about 4 inches of sidewall. Most often they come with at least one heat well below that. The plumbing comes into that heat well down about frost free zone. They're not ice free, but they are relatively easy to break. The black color absorbing sunlight aids in that. There may be as much as 2 inches of ice on these occasionally, but after breaking the ice around the edge and around the float, I like to throw the ice out of these smaller diameter tanks. There are many brands of these super insulated tanks. We cannot cover all of them in this video, but the designs are very similar. The tanks work well on pressurized systems. Some of the differences in the models are the types of lids or doors that are on these tanks. Some of these tanks use balls to float up and close the lid. Others use doors. But the thing that is common in all these, they require daily use. Notice all of these indicated require 2 to 3 volumes of water to be used on a daily basis. The purpose of that is what keeps these waters from freezing. Rather than using heat elements, they are using the warmth of the water coming to the tank. As I said before, pond water is colder than well water. So if you are using a pond water source, instead of needing 2 to 3 volumes, you may need 3 to 4 or more volumes of water used every day to keep them from freezing. This is the inside of a Ritchie waterer. Note the plastic valves. Most all the super insulated waterers use a similar type plastic valve. The concern happens is, what do you do if you have a plastic valve freezes? One of the simplest ways is to use hot water. Go to the house, put hot water in an insulated cooler, and dribble that hot water over this valve body. If the valve has not been froze for very long, you can thaw it out enough that it will start dripping, drip, drip, drip. Eventually, you will get water cycling through it again. Hot water is by far the easiest way to thaw these. Like I've said before, not all livestock water is the same, at least when it comes to winter.
Well water is significantly warmer than pond water.
Well water tends to be in the mid-50s area and maintain that temperature throughout the year. That's due to the soil insulating that deep water. Pond water varies greatly throughout the season. In the wintertime, pond water may be 40 degrees Fahrenheit, or in the summertime, that pond temperature may reach 85, 90 degrees. Rule water, on the other hand, is somewhere in the middle. We consider the frost line, that is, 36 inches here. That's a zone that we typically believe will not freeze, but that can get quite cold in the wintertime as well. Remember, if you have pond water at 40 degrees, that's 8 degrees above freezing, and you have well water at 55 degrees, which is 23 degrees above freezing. That is significantly different. Therefore, it would take 2 to 3 times the water from a pond to provide the same amount of warmth as you could get from a well. Ice is a hard topic to deal with. Number one, it puts this protective cover over the top of all of our livestock water. Yeah, it floats, but have you ever thought about that? As ice approaches freezing, it expands. In fact, it expands about 9%. That's the reason that you get this bursting effect of pipelines and metal valves and things of that nature. The other thing, it requires a lot of energy to freeze ice or to take water to steam. As you move water warmer or cooler, it requires 1 BTU to warm or cool a pound of water 1 degree Fahrenheit. To move it from a liquid to a solid, it has to lose about 144 BTUs per pound. That's quite a bit. That's quite a bit. Or when you move it from liquid to steam, it takes 970 BTUs per pound. That's the reason that ice is so hard to deal with. It's all this energy that it takes. And that's the reason that the warmth of our water sources have so much to do with keeping livestock tanks from freezing.